Hello friends, welcome my channels. Today I want to discuss uniform convergent and pointwise convergence. So friends, let's start. Friends, before learning this, you should also have an idea about sequence convergence. So you need to learn sequence and convergence. So friends, let's start sequence of functions. Friends, sequence of functions I want to discuss. Let D be the subset and for each n belongs to capital N, let f such that D tends to R be a function, then fx is a sequence of function on sequence of function on D to capital R, where x belongs to D. Let 0, 1 and fnx nx divided by fnx, I will write it is fnx 1 plus nx, where x belongs to capital. So friends, you see that x is equal to here x is equal to 0, then if 1 0 is equal to 0, if n 1 equals to, and when x is equal to half, then fn half equals to n by 2 plus 1 plus n by 2 each xn belongs to capital D. The sequence fnx gives to a sequence of real number, to a sequence of number. I will give an example so that you can understand the concept. Fx is equal to x to the power n, such that x belongs to 0, 1, where x is equal to 1 by 2 whole to the power n, 1 whole to the power n. It can be okay, it can be 1 by 2 whole to the power n, no problem. If 2x is equal to 1 by, and if 3x is equal to 1 by 3 whole to the power n, if nx 1 by n whole to the power n. So friends, you see that they are all in sequence, friends. Okay, it may be it is if 1x is equal to 1 by 1 to the power nx. So friends, In the case of uniform convergent, all the sequence convergent. In both cases, all the sequence should be convergent. Uniform convergent, so pointwise convergent. So friends, let's start to the definitions between. We will discuss the definitions of uniform convergence and pointwise convergence. So let's start to discuss the uniform convergence. A given sequence of function f(n)x in domain capital D, the f(n)x is uniform convergent if for every epsilon greater than 0 there exists a positive integer n epsilon such that mod of f(n)x minus mod of f(x) less than epsilon whenever n small n greater than capital N epsilon for all x belongs to capital D. These are the definitions. So friends, now we discuss these definitions with a diagram. I draw a axis and now I want to discuss this is pointwise convergent. Pointwise convergent. And this is uniform convergent. So friends, you will see that this is the graph and this portion is called f(n)x and f(x) is in this is f(x) this portion is called fx and this is a point at x0. Here we fixed x values, so this point is A, this point is B, and this point is x0. This point is A, this point is B, and this point is, this is the function, and this is the same case. In case of it is a pointwise convergent. Here I discuss. I draw this. This is the axis, x-axis. This is the x-axis, and this is y-axis, and this point is fx0, fx0. So friends, you can see that this is our neighborhood would be this way: fx0 plus epsilon and fx0 plus epsilon. So friends, this is the way, and this is the point of convergence. Point of convergence here n is dependent on, capital N is dependent on epsilon and x, and here n is dependent on only epsilon, not x, friends. Must remember, only epsilon, and here n is dependent on epsilon. Here you can see, we will see that here convergent inside NBD neighborhood of fx0. Here convergent point inside NBD of fx0, and here convergent point inside the entire domain. So friends, we see it is entire domain. Now friends, here is, this is the, and this point is fx plus epsilon, this point is fx minus epsilon, and this is fx, this is fnx, and this is fx. So friends, whatever you see that convergent inside entire domain. Here we see, and it is n is dependent only for epsilon, and here n is dependent on epsilon and x. Here convergent point inside NBD of fx0. So friends, I hope that I clear the graphical concept. So friends, now I want to discuss the uniform convergent test of uniform. So friends, it is the two type. Uniform convergence are two type. One is series, another is sequence. So friends, sequence are Cauchy generalized principle. Number 1, number 2 MN test, number 3 uniform convergent, uniform CGT convergent and continuity differentiability and uniform continuity and differentiability test. Number 4 is uniform integration test. Uniform CGT and uniform convergent and integration test. And in case of series, there are three type of test. Number 1, Cauchy generalized principle. Number 2, M test. Friends, you see, in case of series, this test is called M test. And this test is MN test. So friends, this portion is very MN test is very important, and M test is very. Number 3, Dirichlet test or Abel test. So friends, we have learned that the test of convergence 3 ways. So friends, we use MN test. In case of series, we use MN test and M test. Now in case of sequence, we use MN test, and in case of series, we use M test. Maximum test are we use this test. So friends, let's go to solve some problem. So friends, now we want to discuss this problem. This type of questions is very important for CSIR and NET, GATE, a lot of competitive examinations. So let's start to discuss this problem. So friends, at first we have to check that this point is pointwise convergent. After that, we will check that it is uniformly convergent. Must remember friends that if it is uniformly convergent, This means it is point-wise convergent. But converse is not true. Means point-wise convergent means not it is uniformly convergent. So friends, I discuss these examples. Let's start. Point-wise limit answer. Point-wise limit equals to fx equals to limit n tends to infinity fnx equals to 0 for all x belongs to I. I is any closed interval. Therefore, mod of fnx minus fx mod modulus is equal to mod of x plus 1 plus n x square. This is the first method, friends. This method is first method. I will discuss two methods. First method and second method I shall discuss. So friends, whatever we get fnx is equal to fnx value this and fx value is minus 0. This is the fx values. So friend, we can write that x divided by 1 plus n x square mod modulus equals to I can write it mod of t. This mod of t. So friends, t is equal to x plus 1 plus n x square. So I have to find out max and mean values. So friends, for max and mean values of t, we have dt by dx equals to 0 and dt by dx is equal to 0. So friends, whatever I get that implies 1 minus n x square is equal to 0. Simple, it is just derivatives dt by dx. So friends, we get 1 minus n x square is equal to 0. As we know that dt by dx is equal to use u by v formula. So this portion is 1 plus n x square whole square and first derivative is 1 plus n x square and second minus x into 2nx. So this value is 1 minus n x square divided by 1 plus n x square whole square. So obviously you will see that you can see that this portion must be 0. So 1 minus nx square is equal to 0. We get, therefore we get x square, x is equal to 1 by root over n plus and minus belongs to I. And if double derivative using equation 1, if we use this equation, so we will double derivative, because d square t divided by dx square is equal to minus 2nx divided by 1 plus n x square minus 4nx into 1 minus n x square divided by 1 plus n x square whole to the power 4. So friends, we see that if x is equal to 1 by root over n, if we put this value, so we can get this value is minus root over n divided by 2 less than 0. So t is maximum. So friends, whatever we get t is maximum when x is equal to 1 by root over n, and maximum value of t is equal to 1 by 2 root n. So friends, this is the total formula, and after that mn is equal to supremum is equal to mod of fnx minus fx such that x belongs to I. Equals to 1 by 2 root n, and by the mn test, limit n tends to infinity, mn equals to 0. Limit m tends to mn equals to 0. Hence, it is convergent. It is uniform convergent. Now friends, we discuss what is mn test. And okay, another factor is second method. I want to say there is two type of method. Second method, shortcut. In examinations, we need shortcut technique. So friends, when this type of questions will come, this type is n to the power a, x to the power b divided by 1 plus n to the power c into x to the power d, then then AD minus BC less than 0, it is uniform UC. So friends, my question is, x divided by 1 plus nx square. So friends, comparing with this is A and this is B. Here n to the power 0, x to the power 1, n to the power 1. So 0 into 2 minus 2 into 1 less than 0, means minus 2 less than 0. So friends, it is clear that it is UC by the shortcut technique. UC. Now we will discuss that what is MN test. We discuss about MN test. MN test is, let Fn be a sequence of function defined on a matrix space capital X. Suppose limit n tends to infinity, x tends to infinity, so n tends to infinity fn x is equal to fx, and set Mn is equal to supremum of mod of fn x minus fx such that x belongs to x, then Fn converges uniformly of F. If and only if Mn tends to 0 as n tends to infinity. So friends, thanks for watching. I will make a lot of video based on uniform continuity because it's not sufficient to discuss everything in one video. Thanks for